Hello everyone, Namaste. Welcome to MC Forum. Today I am going to introduce about our solar lab business which is contributing towards sustainability of solar industry. I am Puneet Kumar Maurya. You can call me Puneet. I work for MCIND in MISD Business Division and I am responsible for developing business of solar services and products in India. My technical qualification is into printing technology and I have done post-graduation in business administration in the year 2008-2010. Previously, I have worked with a US-based MNC which is into specialty food packaging application. Since 2014, I have been working with Mitsui Chemicals India where I started from packaging business division. From 2018, I have been assigned the task of solar lab business. Here, I have been associated in construction, equipment purchase, obtaining regulatory approvals and accreditation and then to start the business operation of the solar lab. Now coming to the agenda or the contents of my presentation. First, we will discuss about the need of solar energy in India, which will include current energy scenario in India, current market of India, then the roadblocks for the industry's sustainability and how MCI Group is supporting this industry. So coming to the energy scenario of India. India is a developing country which has a huge appetite for energy. In this journey of development, it is also striving for clean energy. Energy consumption in India has more than doubled since 2000. Over 80% of India's energy needs are met by three fuels: coal, oil and solid biomass. All three are primarily fossil fuels. This has resulted in various social issues. If we go on to discuss about social issues, one is the climate change. India is the third largest global emitter of CO2 despite low per capita CO2 emissions. Second is air pollution. Pollution is one of the most sensitive social and environmental issues in most Indian cities. Energy demand. The rising energy demand cannot be met by depending just upon fossil fuels. Now, opportunities for solar energy in India. Our sun gives 5,000 trillion kilowatt hour energy per year over India's land. As per an assessment by National Institute of Solar Energy (NICE), if only 3% of waste land areas are covered with PV modules, the country's solar potential will be about 748 gigawatt. Keeping these potential opportunities and need of the hour, National Solar Mission (NSM) was launched targeting to install 100 gigawatt of solar power by 2022. This target is now updated to 280 gigawatt by 2030. This is in line with India's intended national determined contributions, target of which is to achieve 40% of electric power from non-fossil fuel based energy resources and to reduce the emissions intensity of its GDP by 33 to 35% from 2005 to 2030. As I mentioned that government has given big targets for installation of solar energy. Cumulative solar installation target by Government of India is to set up to 280 gigawatt cumulative by 2030, which has resulted into growth in the annual module production capacity which will be about 130 gigawatt per annum by 2030. India's current solar power installations are also very high. The leading states into this are Rajasthan, Andhra Pradesh and Gujarat. If you see this slide, there are many stakeholders. This is a pictorial representation of all the stakeholders involved in the solar energy value chain. At core of it, there is the asset, which is the solar power plant, which can be of either ground mounted or rooftop. One side is the government and its agencies like SECI and NTPC, along with the state distribution companies. Other side is the financial side, which includes types of investors such as banks, insurance companies, lenders and etc. There is another side into this value chain which is involved into construction of any power plant, PV module maker, basically which are further connected into encapsulant manufacturer and cell manufacturing companies. There are also developers who are involved with EPC companies and landowners. There are few stakeholders to whom we are supporting directly or indirectly for our solar business, which I will explain in the later slide. Now the roadblocks for the sustainable growth of this industry. Currently this industry is facing some challenges. One of the major challenges is reliability of the solar power plant. Ideally, a solar power plant is expected to last up to 25 years, but most of the solar panels start degrading in the initial 4 to 5 years only. This is one. Second is availability of the raw materials. As you know, Indian solar module production is heavily depending upon raw materials which is coming out of one source, which is China. Then third is lack of quality manpower also. There is a scarcity of skilled manpower, skilled technicians, skilled installer, which actually goes on to the field and install that solar power plant. Then of course there is a lack in the quality of the controlling measures at the production level of a solar module or its component, and also the installation level. There is also lack of standards, lack of basically local standard. Of course there are international standards available, but we need an India specific or Indian geography specific standards. There is also non-availability of calibration services when it comes to laboratory services. There is also lack of meteorological traceability, which is not available locally, and we have to be dependent upon European companies for this purpose. There are several issues with the policies also, and of course there are many stakeholders. So in a nutshell, there is nobody to take the blame when any power plant fails. Now, what is our contribution in this value chain? So MCI group contributes to the solar energy mainly into two groups. One is the material supply group, one is the services. In the material supply, we supply materials to the module manufacturer. So we supply encapsulant film, which is under the brand name of Solar EVA, as well as Solar ACE. We also supply materials to the manufacturers, to the film manufacturers. So we supply polymers such as EVA Flex and TAFMER to these encapsulant film manufacturing companies. Now the second group, which is solar lab testing services. So of course we supply the lab testing services through our lab, which is based in Ahmedabad. We also do testing as per Indian and international standards. We also support module manufacturer for certification. And the last point is about the solar consulting services, wherein we can provide our technical due diligence, energy yield assessment, performance ratio, support for insurance claims, etc. to any owner of a solar power plant. Currently these services are limited to Japan, but we are now trying to bring these services into India. Solar lab testing and consulting services both are based out of our solar lab, which is based in Ahmedabad, Gujarat state of India. Now I will explain about material supply to module manufacturers. So we supply the encapsulant sheet to solar panel manufacturing companies. Solar EVA and Solar ACE are the brand name of Mitsui chemicals, which are of different types of materials. So these both types are very popular among the module manufacturers. Encapsulant function is to protect the solar cell from physical and weather damage. So the second part of the material supply, we supply polymers to encapsulant film manufacturers. As I mentioned earlier, we have two polymers mainly. One is EVA Flex, which is ethylene vinyl acetate copolymer, and second is TAFMER, which is alpha olefinic copolymer. These polymers are used to make different types of encapsulant film. Currently in India as well as in the world, only these two types of encapsulant films are popular. Now the solar lab services. These lab services are based out of Solar Lab in Ahmedabad. This is a world-class testing facility constructed in technical collaboration with PI Berlin, Germany. Recently, we also had joined hands with Bureau Veritas for testing business in India. This lab is NABL, which is National Accreditation Board for Testing and Calibration Laboratories in India, which qualifies this lab as per ISO 17025:2017 standard. This lab is also approved by BIS, which is Bureau of Indian Standards. Now I will explain more about this lab. How does it work? In simple words, the lab follows ISO 17025:2017 version, which basically tells us about the requirement for the competence, impartiality and consistent operation of the lab, of any lab for that matter. So for solar panel testing, we test them as per the international standards, IEC standard, or sometimes Indian standard, wherever is applicable or as per the customer's requirement. Now, the factors affecting testing, or in other words, I will explain about the USP of our testing lab. As you can see, whenever we do any testing, there are several controllable and uncontrollable factors which affects the accuracy and quality of the testing result. Our system, our management system and quality management system maintains a high level of quality control measures which are required at every point to ensure minimum deviation of testing results. This is what is our USP. Herein we bring along expertise and experience of Japan as well as PI Berlin based in Germany. Now, to ensure quality and accuracy, in first I have already explained about our management system, and second part is about the quality of the equipments. So, here you can see some of our major equipments. Our lab has flasher or sun simulator which is A+, A+, A+ rated. We also have wet leakage for checking the leakage current. We have mechanical test area for all the mechanical tests related to a solar panel. We also have dark room for all imaging tests related to solar panel. We also have environmental chambers for simulating harsh and accelerated environmental condition. We also have a steady state sun simulator. So, whenever there is a cloudy sky and we cannot run a test in a cloudy environment because there is no sun, we can simulate the sun inside our lab as well. And of course, there are many more equipment which unfortunately I cannot show in this introduction. Now, I will explain how we are combining our experience of materials with solar lab services and trying to offer solutions to the solar industry. You can see the table with various stakeholders and our services offer. To a developer, we are trying to offer reliability testing services, which is a combination of solar lab testing services and our experience. We can also offer root cause analysis for identifying failures, cause, for insurance claim settlement and for process improvement. We can also offer energy yield assurance using historical weather data for long-term planning and forecasting. To a module manufacturer, we can offer factory audits for qualifying factories for module supplies. We can also offer quality assurance services to ensure high quality production of solar modules. To a module manufacturer, we can also offer testing services for obtaining BIS certifications. We can also offer quality testing packages as a third party for validation of their performance. We can also offer reference material for their internal quality control lab. To an encapsulant manufacturer, we can offer material testing services when they are manufacturing encapsulant and backsheet. We can also offer raw materials for manufacturing encapsulant sheets. This brings us to the end of my presentation. If you have any queries, you can contact me, or if you have any questions now, you can use the chat box. Thank you very much. Thank you for listening.